In previous years, I've talked about implementing the module specification and how that module specification has changed during the development process. This year, I'm going to talk about how to convert some existing code to modules. I'm not going to talk about why you would want modules. We're going to take that as a given. It's going to be in C++ 20, so it's here. I'm assuming that you saw Gabby's talk yesterday. Who here did not see that talk? Okay, right. Oh, well, okay. I'll hopefully cover enough of it, of modules that this talk will make sense. The implementation I'm going to talk about is GCCs, because that's the one I've been writing. It's experimental. It breaks. It's on a development branch. It's not in trunk. It's not in any released version of GCC. Wiki page here that talks about the state of that development and how to use it. Short answer is you just invoke it with this fmodules ts option, and it will be in modules mode. For this talk, I decided to actually go and convert some existing software, and I picked a library that I did not know about. I looked on the ISO-CPP webpage and found tinyxml2 as an example library. The original is on GitHub. It's by Lee Thomason. Go there if you want the real thing. I cloned it to here, which I then ripped out all the bits that weren't relevant to this talk. So after this talk, you can go and look at that GitHub repo and see the commits that I've made. I've got a link at the end as well. So this talk may make more sense watching it on YouTube. How do I go back? There we go. Right. It has one header file. It has one source file which has got the implementation in it of all the non-inline stuff. It has one make file. It also does CMake, but it has a make file which I liked because I know too much about make. And it has one test program which the make file builds and you run it, and it runs a bunch of tests. So it's a fairly straightforward library that I thought was a good candidate for this conversion. So step 0. Let's make sure we can actually build it with the new compiler when it's unchanged. So the only change there that I made is adding this line into the make file. Point the CXX variable at my new compiler and turn on modules mode for it. Run make. Run make, and you get a number of build commands. It builds the library, CPP file, turns it into a lib archive, builds the test program, run the test program, all the tests pass, hooray, this compiler's not completely broken. Okay, so bit of background. So this is a bit that Gabby kind of covered in his talk, and Boris covered a bit in his talk this morning, is that when you build a module, you get an object file, but you also get this new artifact called a compiled module interface. It's also called a BMI, a binary module interface, but it might not be a binary. But whatever. You get this new artifact that we have to teach the build system about so it knows dependencies between things. And as Boris covered this morning, there's no defined relationship between the file names of the CMI file names, and the module name that they're a CMI for. That's implementation defined. I'm going to cover a bit of that for how. And also, these CMIs may be placed in a particular place in the file system where that is again, implementation defined. So there's a study group, SG15, is looking at what it would be best practice for these to answers for these kind of questions. So, simplest kind of the easiest conversion is to turn it into a header unit. A header unit is a way of taking an existing header file and producing a CMI from it. Now, that's a simpler conversion because you basically point the compiler at your header file, and that's going to be essentially it. But you don't get all the benefits of modules, and you can't do it to every header file. The header file has to have certain constraints. In particular, it shouldn't be a header file that's intended to blat out, templated code via macros because history. The tiny XML2 header file should be okay for this. You can explicitly import them in the source code. You can say import and then a thing that looks like a header name, because it is a header name with a semicolon on the end. It starts off being a bit strange, putting semicolons on the end of something that conceptually you think is a header file, but you get used to it. Or they can be implicitly imported, which is where you've told the build system and compiler that when it sees a hash include of tiny XML2, it should treat that as if it was an import and read the CMI. And then it won't textually include the tiny XML2, it'll just go off and read the CMI. And that's one way of improving the build speed using header units. So, how do we do this? Step one is we're going to turn tiny XML2 into a header unit. Now, the first thing that I need to do is create some kind of representation of how the file names relate to module names. And that's called a mapping file in the GCC implementation. So here's the header name, tinyxml2.h, and it has to look like a file name with a / in front of it, because otherwise it could be a valid module name called tinyxml2.h, and that's not what we're trying to do here. And we're going to put the CMI into this file here called tinyxml2.h.gcn. And this $root thing is just saying, oh, and put all the CMIs in dot in the current directory. Then the other change that we have to make is to update the make file by essentially telling the compiler that it should look at that mapping file. So that's what this module mapper equals mapping is. I should probably have added this to flags rather than CXX variable itself, but oh well, never mind. And I'm also adding this other option, note include translate, because if this all goes well, it'll behave just as if we hash included it. So unless there's something telling us that it did this translation, we would be none the wiser. And we need to add a rule to the header to the make file to say that the GCM file is dependent on the .h file, and this is how you build it. Invoke the compiler, add this other option, fmodule header, to say this file that I'm feeding you is a header file, and you should turn it into a header unit. That's normal make gumph here with the $angle brackets. Oh yeah, and then the other change is on the make file is obviously there's a dependency change now that building the library implementation file is not dependent on the .h file anymore, but dependent on the GCM. So we don't make any changes to source code at this point. We're just telling the build system there's some more dependencies and creating this other file that the compiler and the build system know about. So, this would have been animated, but I'm giving the punchline away now. Never mind. So here, we build the header file at the first step, and then we build the CPP, the implementation file. And we get this diagnostic note to tell us that, oh, that hash include that was in tinyxml2.cpp got turned into an import. And that's our only indication that this actually worked and I got it right. Hooray. Then that turns into library as before, and then we build the test program. And you'll notice that actually we've got 3 compiles going on here, whereas before we had 2 compiles because obviously this first step here didn't happen. Let's go back. There we go. Right, so tinyxml2.h gets turned into an import, and then we get this error thing happening at the bottom. This is actually an interesting error because it shows some of the behavior of what's happening behind the scenes when you're dealing with header units. The short story of this is actually it's a compiler bug. But you'll see it's got confused by pointing at the same type def twice, and you go, this is a bit strange. Why is the same thing problem, particularly as it's a type def. But what's actually going on here is, I'm going to take a slightly different example with a class, because that you can't multiply define, whereas type defs are allowed to be multiply declared. As long as they're declared to the same type, you're all okay. Hence, compiler bug. But here in header land, you'd define your class in a header file. You would include it in some other header file that for instance, wants to make it use it something. And then your source file may include both those two header files. And of course, this thing here, when you do the second include, you're going to get a compile error at this point because you've got a multiple definition of widget. So what you do, you put header protection around it. And then we're all okay. And what's happening here, of course, is that you're preventing the textual stamping out of the second the nested include of widget here by its include guards. So the compiler only sees one set of tokens for widget. Header units are slightly different in that include guards essentially don't work on them. So this is the code that I just showed you here with the header guards and a hash include, and we've turned this hash include into an import. So what's actually happened here is that we've textually included the widget header file, seen a definition of widget from here, and we now know about the widget class. But we've also imported foo.h, which itself had textually included widget, and because that wasn't a header unit at that point, it itself has made this definition of widget visible. And so we end up here at this import having another definition of widget, and the compiler has to now go and merge these things and figure out, oh, these are actually the same widget. I've only got one entity here, so I haven't got any ambiguity. Now, this kind of merging of entities is a thing that happens with header units because they're from header files. And it's now happening in the compiler rather than happening in the linker, where the linker goes, well, these are obviously these have to be the same, I'm just going to assume it, and weird things happen if they're not. The compiler now has a chance of actually detecting that these things you said were the same are not the same. That's a quality of implementation issue. Anyway, so at the point I got that error, I wondered, precisely how robust this compiler was and whether it was a bit too early for prime time. So I was having a think. Anyway, several compiler fixes later. Hooray, it doesn't give us this error at the bottom. And I actually added the note include translate at that point because I realized I hadn't actually got any indication that we've got the translation happen. We run the test, everything runs, the tests pass, we're all good. Okay, so we've now got a header unit. Are there any questions or is this not unclear? Oh. Do you want to talk to the mic?
I was just noting the position-independent code flag. I was just curious.
Mm-hmm. That was on the original library. So the XML library builds as pick. So that's why that flag is there. Whether those kind of flags affect the shape of the CMI is rather dependent on what the flag is. I've taken a more relaxed attitude to that at the moment. Now, when I first started, I was quite paranoid of avoiding problems and forcing them all to be the same. But essentially, the pick one goes all the way to the back end of the compiler, so the front end doesn't really need to know about it. The library may generate different things because there's a hash define that tells it whether its pick is on, and it may have different ASM inserts. Your mileage may vary. Okay, so step number 2, we can turn this into an explicit header unit. And this is where we start changing source code. We change the hash include tinyxml2.h into import tinyxml2.h, and we do that in the implementation file of the library, and we can do that in XML test. We don't change the build system at all at this point now at this step because that's just the same. It needs to build the header unit and then compile the sources. But you'll notice here when I type make, I'm not rebuilding the header unit because I didn't change anything in the header unit. It's already there. I didn't do a clean build at this point. So I got the two compilations of the library interface unit and of the test program, and you see there's no note that include translation happened because I explicitly said do the thing. And hooray, everything passes, we're good. So we can now relax again. So the next bit is the main event of turning it into a named module, which is where we want to all get to. And just to recap on what others talks have talked about, is that a named module looks like this. You've got a module semicolon at the front, followed by a global module fragment where you put all your hash includes. Okay, and that's legacy hash include stuff goes there. If you have no legacy hash include stuff, you don't need the module semicolon. You can just start with the module purview where you say module and then the name of the module. And if it's an interface unit, you will put the export here to say this is an interface defining the interface of tinyxml2. And the thing called the module purview starts at this point. So everything after this is regular declarations and they're owned by that module. And you can put imports, explicit imports at the beginning of this purview. Imports of both other named modules and imports of header units. You can put them up here in the global module fragment, but there's no difference. So you may as well put them down here. The immediate question you need to ask about to yourself is whether the implementation, whether your header file is making macros visible to the user, because at this point they will stop working. So if they do, you need to redesign your API or stop. That's one of the significant differences between header units and named modules is header units preserve the macro behavior of header files and make those macros visible. But they don't, unlike header files, they don't pay attention to macros that were defined before you imported them. So they're somewhat isolated from macro pollution, but they will pollute other textual code that appears after them, after their import, with the macros that they themselves exported or made visible. So, pick a module name. Obviously, in this case, I'm going to use tinyxml2 because that's the name I have. And then I'm going to rename the header file to a source file, because it's a source file now. It's no longer a header file. It produces an object file. So I just renamed it tinyxml2-m.cpp. I don't see the need to change it to a different suffix there. If you change it to a different suffix, a new suffix, you have to teach all your tools about the new suffix. And besides, if you have a new suffix there, it leads to the thinking that it leads to breakage on build systems that assume they can just take the suffix off and replace it with a .o or a .d or whatever to get a dependency file or the name of the object file. There are other ways of making it clear that this is an implementation file. -m is there. If your file system understands is not case folding, you can give it a capital letter maybe, lead it with a prefix. There's a lot of scope there. This one worked for me. And I'm going to edit the interface file. So the interface file, tinyxml2.cpp, tinyxml2-m.cpp. We can take out the if-def header protection. We don't need it anymore. It's just confusing. And we want to insert a global module fragment into it. So that means put a module semicolon right at the beginning of it. And then we need to put the module purview to start after it's done all its hash includes of std.io and whatnot. So after those, we can put export module tinyxml2 to start the module proper. And to make things simple at this point, we're just going to export everything from the module. Everything was visible before when it was a header file, so exporting everything at this point is not going to make more things visible to the user. And we can do that by export squiggly brace just after this module declaration and put a squiggly brace close at the end. So this is one of the ways of saying export. This is a way of saying export a block of code in a similar way that you can give C linkage to a block of code with extern C or whatever. It's exactly the same idea. These squiggly braces are not a scope. Right. Change the implementation file. We've now got tinyxml2.cpp, which was the library implementation before, is now a module implementation. We take out the import tinymxl2.h that was there, insert module semicolon at the start. It's got a bunch of hash includes, and then we put module tinyxml2 after those includes, without the export there. So this is saying this is an implementation unit. It's going to stamp out some code, but otherwise its contents are not visible to importers of the module. And we edit the test program, so not import the header unit, but import this named module. It's a fairly simple change. Right. Oh, yes. And now we have to change bits of the build system, because we no longer have a header unit module. We have a named module. So we change the mapping file, and we probably don't want to put it in the same place as before, because that would just be confusing. So we'll put it in a different file, and the name of the module is just tinyxml2. And we have to update the make file by ripping bits out of it, because of course now the GCM file is a different name, so we change the name there, and it's dependent on the -m.o file. This is a bit of a sleight of hand in make, because it's produced at the same time as the .o file, but if I do it this way, make will already have an implicit rule for generating a .o from a .cpp, so I don't have to teach it any more stuff. And I can just say that this GCM is dependent on the .o, knowing that when the .o is produced, the GCM is produced. But I have to explicitly tell make it doesn't need to do anything, because otherwise make goes off and tries to find an implicit rule, and it'll fail because it doesn't have one. No longer need this explicit build of header unit, doesn't exist. And a bit of changing in the dependencies of the interface of the implementation file. And of course, now I've got another object file that I need to add to the library. So the library now actually contains 2 object files rather than 1. And I build it, and it builds the interface file quite happily, hooray. Starts building the implementation file, and I get a whole slew of errors. And I'll go through it. This is not unsurprising. And I will go through why I'm getting those errors. And you will be convinced the reason behind those errors are good things. So, first error, oh right, yeah, okay. Picture. First error was this one. Error, VSN printf was not declared in this scope. So what's happened here is that the implementation file was relying on a hash include that had been included by the header file, but wasn't part of the header file's interface, because it couldn't do anything else. It hash included std.io, which gave it this printf function. But now that's a named module, that visibility of the std.io that was included in the header in the interface, in the module interface, was not exported to anything that outside of that translation unit. So no wonder when tinyxml2, when the implementation file looks up for this name, it can't find anything. Similar in XML test, that had the same problem. It was relying on that hash include. So the obvious solution is, well, you explicitly include all the things you depend on. So this problem with implicit dependencies that you can get through nested header files goes away, and your dependencies become explicit. So that solves that not declared in this scope problem. The next one is this tixml assert was not declared in this scope. And because it's in uppercase, you assume it's a macro, and you're correct. It's an assert macro that's used internally in the interface file now, and was also used in the implementation file, but of course the implementation file can't see the macros from the interface file. So we can either abstract that out into an internal header file and include it in both places, or we can just cut and paste it if we're lazy. I was lazy. I cut and pasted it because it was one macro, and I incurred some technical debt which I will pay back by the end of this talk. And of course, the XML tests, the test program tested this macro, but it actually tested this macro passed. But of course, this macro was being tested implicitly because it was in all the bits of code paths that were being tested by the XML test. You don't really need an explicit test in that, so I just deleted it. But you can do the same thing if you abstracted it into an internal header file. Okay? Fix number 3 was this tiny XML2 max element depth was not declared at this scope. What was going on here is that tiny XML, the header file contained this internal linkage constant. That was used only inside the library as far as I can tell, but I'm not quite sure. But this is the thing where putting internal linkage things in header files means that can't be explicitly exported. So this is actually another compiler bug where it was failing to detect this problem when I compiled the interface. It should have shouted at me and say, hey, you're trying to export an internal linkage thing, stop. I haven't got all the errors in yet, all the error checking in. It didn't export it, it wasn't visible, so at least some goodness happened, something was right. And we can either make it not external, not an internal linkage thing by dropping the static, or we could make it an unscoped enumerated value because it's an int, that works. Or if neither of those things are we could have not exported it by closing the squiggly brace of that block export and reopening it just afterwards. And then it would have either internal linkage, or we could make it module linkage by dropping the static. It would then get module linkage rather than external linkage. Anyway, I chose this last approach because that's the one that worked in this case. Right, so compile it. This time it compiles okay, and all the tests pass. Hooray, we've turned it into a named module. So there we go, we've got something there. Any other questions at this point? Do you want to use the microphone?
On slide 25, could that be const expert instead of the enum?
Yeah.
Okay.
I mean, like I say, I'm taking an existing library. It is what it is. You know, I'm sure, anyway. Right, so this library is quite a small library. It's a few thousand lines of code. But we've maintained, when it was a header file, we had a header file and a source file pair, because that's how header files and libraries work. And we've copied that model over into module land with an interface file and an implementation file. But we don't really need to do that. We could put all our implementation in the single interface file. There's nothing wrong with it. It produces an object file. We can emit code from it. Unlike a header file, of course, you can't put things that emit code directly inside a header file because you get, obviously, link errors at that point with multiple definitions. So we're going to turn it into a single file module. And to do that, we're essentially undoing some of the things we just did to make it a named module. We can copy it. The implementation file had some unique, there we go. Yeah, the implementation file, tinyxml2.cpp, had some unique hash includes that weren't in the header file, the variant or the interface. So we need to copy them into the interface's global module fragment. I think there was one, I think it included new or something, I'm not sure. Anyway. And then everything after in the implementation file after the module declaration, which is part of the implementation of the module, we just copy all that text and stick it after the closing squiggly brace of the big export block that we created. And then we can delete the implementation file. We don't need it anymore. It doesn't contain any implementation we don't need. And then we simplify the make file. We can actually get rid of this implicit, this dependency fudge that I actually put there, And then the library goes back to being made from one object file, but this time it's the object file that came out of the interface, which has got this name, rather than the object file that came out, rather than originally the object file that came out of the single source file, this name. And we change the dependencies slightly because now we've got the implementation file we need to tell it about. And we build it, we only get 2 compiles this time rather than 3. So we're back to the original 2 compile jobs going on. Run all the tests, and they all pass. So hooray, we're now actually, I'm going to get, so this is as far as I wanted to get, because now I can go further, but it requires more semantic information about the library and its API and stuff like that, and I don't know the library very well. In fact, this is about the sum total of my knowledge of the library. But there are a bunch of stuff we can do. Oh, right, yes, I've repaid the technical debt, by the way, because I threw away everything from the implementation file that was before the declaration here. I threw away everything that was a copy of the unique includes, copied the stuff that was after that declaration, and then threw away the rest of it. That cut and paste job that I did with that macro has now gone away. I've only got 1 copy of that definition. So it was a temporary hack to get where I wanted to go. So this TXML max element depth, I mean, I'm exporting that, but that's actually an internal piece of the library, so I don't need to export it. I can turn everything, rather than export everything, I should just put individual exports on the pieces that I want to export and not put it on the things that I don't want to export and things that are internal use only. The other thing that I've probably ended up with at this point is I've got separated declarations and definitions, because I essentially did this by textual pasting of code. The original library will have declared an entry point function, the original header file. I've put an export in front of that, and that's the sum total of that declaration. And then later on, I've pasted the definition that was in the source file of the library, and I've now pasted that in. So further on down, I've got the definition of that file. So I've declared it, I've written the same thing twice, which is probably, I think, going to be a maintenance burden. I can just put it all in one declaration, stick the export on the definition, move the definition up the front if that's where I need it to be. There's no particular ordering constraint on where you put the, how you mix exported and non-exported entities. What you can't do is declare a thing and then decide to export it in a later declaration. You have to export it at its first declaration. But later declarations inherit the export in the similar way that later declarations of functions will inherit an explicit static or that kind of thing. Right, okay, so this is the Git repo. It's there, and this is the mapping onto the slides of the various commit messages that are in that. You can guess I flubbed the first commit on that one. There's a v2 commit, but you'll see it. As I say, thanks to Lee Thomason for providing a library that was suitable to convert in the time available. If you want the real XML2, go there to get it. Okay, so I'll open up to questions.
Hi, I didn't attend the other meeting, so this might be answered, but if I want to distribute a binary package of this library, is the .a file the only thing that I need to distribute?
The CMI file should be thought of as a caching artifact. It's clearly tied to the implementation of the compiler, and not just the flavor of the compiler, GCC or Clang or Microsoft or whatever, but in those, it's tied to the version of the compiler. I intend to tie it to the version of the compiler when we have release of compilers, but obviously it's quite tightly coded. It represents the AST, so if the AST changes, this representation changes. At the moment, when you build it, it's tied to the build time of the compiler, because that's the only way I can say same. If you don't want to distribute source code, you're probably going to have interface files and separate implementation files, and deliver the interface file in the same way you would have delivered a header file.
Okay, thank you.
Can you go back to slide 30?
I can give a go. That one.
Yeah. So, doesn't, so what's the dependency line look like for the final library, or for the final, the test file?
The test line, right, the test file depends on the library. It has a dependency on the .a.
Which implicitly has dependency on the
Which then,
.o,
yeah.
which has a,
Yes.
a unstated dependency on
Yeah,
the
I've done a bit, I have
GCM.
done a bit of sleight of hand there in this
Okay.
particular case.
Yeah, so you dropped the explicitly dependency on the BMI or CMI because you're just relying on it getting emitted. Okay. And having an implicit name?
Sorry, having a...
Implicit name. Like what the name of the GCM
The name of the yes.
is based on the name of the
I've
.io?
explicitly done that in the mapping file.
Okay.
If I didn't have that mapping file, you get a default which actually will do exactly what I did in that mapping file, except the root directory is not dot, because cluttering up your current working directory with GCMs turned out to be annoying, so I've just put them in a thing called cache GCM or something.
Okay.
I can't
Thanks.
remember.
I saw that you had the opportunity to pound include files by double quotes or by the angle brackets.
Yes.
Or you had the opportunity to pound include import as well, or
Yes.
you could import the module.
Yes, the actual mechanism there is that wherever you've got a hash include, you can turn it into an import with exactly the same spelling of the file name. Okay, and because of things like config.h, which there could be multiple config.h's that get included by different files in different directories because they're including the one in their own directory. You actually have to resolve that module, that header file, the header unit name to an actual file on disk. So you need the header file there. So what actually happens is, and this is, I believe it's true in the other compilers as well, because it's the only way I can see it working, is you resolve that as if it was a header file to a file on disk somewhere, and then you import using that fully resolved name. So in this case, they all got resolved to // because I used single quotes and there was one right there in the same directory as the file I'm dealing with. But if not, it would have searched the hash include path and found the one you intended and then said, //
You're answering half of my question there, which would be, do the imports then follow system include for the
Yeah, they
pathing
could.
stuff, or do they follow regular include?
It depends if you spelt them with quotes or angle bracket.
Okay, what if I don't use either, if I'm using just module? And my next question, if you want to roll in your questions, are going to be, what if I know the module name is not tied to the file name. Is it possible that I could have a collision between an import file name that I'm trying to go for that has a module that doesn't match and a pound include of something else that has the same name?
So
It just seems like they're both doing the same thing.
Okay. So I think your question is there a possibility of collisions between header unit names, which are hash include names, and they're hashes because that's where I grew up, and named modules which look the same, because I could, as I did mention, that the named module, I could make a named module, it's a dotted sequence, so xml2.h could be a named module name. It would be a very stupid one because it would be confusing. The implementation that I have keeps those distinct and doesn't have the possibility of a collision there.
Okay,
Okay.
thanks.
Hi, great presentation. But my question is, in my project, I have lots and lots of libraries that depend on each other all the way up to, an executable, and converting everything over to modules will be a long, arduous process. And so I'm wondering if you have a recommendation on a, top-down or bottom-up approach on which way I should start converting first.
Yeah, you can actually do it in either way using different techniques. So a top-down technique, you would use the global module fragment quite a lot. You would put all your existing hash includes inside the global module fragment, and then your new module, your new code after the module declaration. Okay? And then obviously as things get converted, you can turn those hash includes to imports and leave them there or move them down, and then eventually your global module fragment evaporates, right? If you went the other way and converted the leafs of your include graph, that would also work, but then you'd end up turning, either using include translation a lot, so that everything that hash included them suddenly started importing them, or explicitly convert them to imports. I don't know which is the easiest way to go. Sorry.
Okay, thank you.
Following up on the question before last, in the pound include world, we have a distinction between my header files in quotes and system header file, iSystem
Yes.
in capital I. Is there a similar distinction with modules? Do we have system modules versus my modules? And where would that be expressed if so?
Yes, essentially the way this is specified is in terms of header files, or in terms of system headers, which may or may not be files, but
Right.
let's just assume they are files. So whatever mechanism your compilation system uses to locate files that would be included, you use the same mechanism to uniquely identify a particular CMI.
Sorry,
Okay.
I'm talking about named modules. Not
I'm sorry?
I'm talking about named modules.
Oh,
not
sorry,
headers.
named modules. Yeah,
Do we have system
that's
named
somewhat
modules?
ambiguous at this point of the best way of dealing with that. So the question you then get there for build systems really is that given an import of foo, I want to find the interface file for that defines foo's interface, so I can go build it. Because I don't want to, because it's like I said, it's a caching artifact, and that is kind of a different question, for which I had a picture actually. I anticipated that. There you go. Not a boat. So again, this is the kind of thing that SG15 is looking at, and there is no well-defined answer to that question at this point.
Okay, and then my other question is the various online compiling tools, Godbolt and Wandbox and Coliru and IDEA and all this.
Yes.
Could I reproduce or play around with this in any of those?
Yeah, I believe Godbolt has and does regular builds of my branch of GCC.
It does have that, but I think only one file at a time.
I don't know. Yeah,
file.
it was sufficient to report somebody to try it and find a bug that I needed to implement. I'm sure. Yeah, we can talk.
Do you plan any tools, or perhaps they are available already, to inspect the content of CMI file, like objdump or nm
Right.
for CMI?
Yeah. So, in my particular case, because these are all bespoke formats, your mileage varies depending on what compiler you're using. I just happen to have used elfincapsulation of this new, because it has lazy loading and stuff, so it basically needs something I can index. The section indexing that elf gives me is fine for what I need. And so the byproduct of that, you get to look at this. And one of these you will notice is a README, and that's intended for human readers and maybe build tools. And it looks like this at the moment. It's just a string section. So it tells you what this thing is, what it was built by. It has some temporal. This is the only information in this CMI that is volatile, and I'm probably going to add an option to enable that or disable that as you require. It's useful to have it if you want it, but if you want a bit identical rebuild, you clearly do not want a timestamp in the CMI. But that's what I have at the moment, and it will show actually the imports, but in this case there were no imports to show.
Okay, and another question. If you merge interface translation unit and implementation translation unit, does it hurt the parallelism of the build?
Does it help, sorry?
Parallelism of the build.
So I can't quite hear your last question.
Does it affect negatively the parallelism of the build? Because all dependencies, like if you have this translation unit separate, then all dependencies can start building after interface is built. And
Right.
if you join it into a single translation unit, they can start only when
Oh,
both of them are built.
sorry. Yes, I understand. So your question is, turning it into a single file module, has that affected the build latency? And the answer is yes.
Should we do this? Should we
Yeah,
do it like
well, it's a
this?
small library, you know. I think, you know, if your library is large, you will probably want to split it up into, maybe even partition the interface itself, but into smaller units purely for a code management thing. You know, offhand, I don't know how much it slows it down. One of the things that gets in this particular implementation is that there's a protocol where the compiler can query the build system as the compilation is going on, and it can, at the end of parsing the source, it writes the CMI and can tell the build system, oh, the CMI is ready now, even though the object file may not have been generated because it's still doing all the optimizations of the actual stuff it's going to emit. So there's a possibility there that, you know, that you can overlap things, but that's kind of speculative at this point. Okay.
Thank you.
And I think John has a question.
I just wanted to ask, to what extent have we been able to limit the private access across module boundaries?
Okay, so I haven't implemented the private module fragment. I have implemented module partitions, both interface and implementation partitions, but I don't do any of the completeness visibility that the implementation partitions imply about imports.
Okay, so let me clarify the question. What I mean is, at the highest level module, what precautions do we take to make sure that we don't have long-distance friendship or any other device that allows us to access the internal implementation, let's say, of a class defined in one module from another?
Right. So you could get that long-distance friendship by you would have to do a bit of work to get it, but because the import graph is a DAG, it's hard to forward. You can't forward declare from one module to another and have that kind of mutual declaration within interfaces. But you can do it from an interface to an implementation, because an implementation file can, of course, import an interface. And so the implementation translation units could see stuff that you can't get at in the interface file. Does that make sense?
I think so, but at the end of the day, what I'm concerned about is there may be, because this is a very difficult part, you know, to sort of nail down, and there are tricks that don't even involve friendship that allow you to get private access using partial specializations and such. I was wondering, to what extent did we go out of our way to make sure to plug every hole so that we don't have long-distance friendship across module boundaries?
Yeah. I don't think that has been explicitly considered at this point, that kind of using instantiations to get around that, what you've just described. So, yeah. Won't solve everything. Okay. So I'm sorry that the showing the slides was not quite as I intended, but and thanks, Boris, for letting me use your laptop to get it on the show. So thank you, everybody.